Hello students, welcome back. We went through solution 1 of this problem, remember? So we want the profit function is r minus c. So from here, taking the antiderivative, we got this. From here, taking the antiderivative, we got that. So r prime to r, c prime to c. And I didn't want to use plus c for arbitrary constant because c is already taken by cos. So I use r0 and c0. Okay, now let's find out r0 and c0 values to get unique solutions of the revenue and cost functions. Cost function is explicit. Cost for producing 10 units is 700. So antiderivative, which I calculated before, and then plug in 700. Plug in 10, x equals 10, and the result is 700. And go ahead and do that. Plug in 10, and calculate. We get c0 equals 100. And that'll bring down to a cost function as this. So this one's done. C is done. How about the revenue function? Well, revenue function can be a bit trickier because there's no initial condition for the revenue directly. But actually, that's easier. Hidden initial condition is right here. There's no such thing as fixed revenue. So if you sell nothing, then you earn nothing. So r of 0 is always 0. So plug in x equal to 0. All these drop down. They're all 0. So 0 equals r0. So yes, r0, the interval constant, turns out to be 0. So we have the revenue function. So alright, cost function and the revenue function, put both of them together into this. This will give me the profit function. Revenue minus cost, we have this. Okay, now that we have profit function, take the derivative, set it equal to 0. Take the derivative, set it equal to 0. Solve it, we have 25, and that is the daily production level to maximize the profit. And the maximum profit, plug in x equals 25 to that profit function. Profit function is right here. Plug in 25 here and run your computation. 1,775. And yes, looks like it's the dollar unit. So maximum profit each day is $1,775. That's one way to handle this. Now let's consider solution 2. Let's consider marginal profit first. So marginal revenue is here, marginal cost is here. So we have here, and that's 200 minus 4x minus 50 plus 2x, and that is 200 minus 4x minus 50 minus 2x. So if I calculate this entire thing, negative 6x plus 150. That's my profit function, or marginal profit function. And then we're going to set it equal to 0 and find out x value from here. It's not a grand conclusion, so let's take another step here. X is 150 over 6, 25. So, compared with the previous problem, I got the daily production level right away in step 1. Previously, we did antiderivative computation, cost, revenue, profit, and then take the derivative and set it equal to 0 to find out the daily production level. But we didn't have to do any of those if you consider marginal profit first. R prime minus C prime, and then set that equal to 0. So for X, we have the optimal daily production level. Now, if the problem is asking only this, that would not have been any kind of problem. But I'm afraid we have to find out the maximal profit as well. So that's going to be a bit of a problem. Let's go ahead and do that. Step 2, the profit function. So an integral of negative 6x plus 150, and that's going to be negative 3x squared plus 150x plus some p naught. That's going to be your profit function if you take the antiderivative. Now let's find out this p naught, and that could be a bit of a problem, because total cost of producing 10 units is 700, okay, and the total revenue of producing 10 units, I don't have that. How about total revenue of producing 0 units? That's 0. But then again, total cost of producing 0 units, well, I don't have that either. So finding this one out directly by plugging in a proof with the x value is going to be a bit of a challenge. How do you handle that? Well, what choice do we have? Find out cost and revenue. Let's see. There's no question about that. If you produce 0 units, then revenue is 0. If you produce 0 units, what's your cost? I don't know that, but I do know this. So from here, can I find something out? Oh, well, cost function is let's see, what is the cost function? Marginal is 50 plus 2x, okay? 50 plus 2x. So 50x plus x squared plus c naught. And then that is 50 times 10 plus 10 squared plus c naught is 700. So from here, I can find out c naught. 700 minus 100 minus 500. So C0 is 100. And then let's see. Revenue function. So R0 is 0. That's because fixed revenue is always 0. We don't need entire thing here. So we get R0 is 0, and a C0 is 100. So let's go back to the profit function. Revenue minus cost. Fixed revenue minus fixed cost. So this is negative 3x squared plus 150x minus 100, because this one is 0. And then if you plug in x equals to 25, plug 25 to all this, and run your calculator, and you're supposed to get the same answer as before. So you're supposed to get 1,700 and something. Yeah, 1,775, the same answer as before. So P0, which I just highlighted in red, is R0 minus C0, because profit is revenue minus cost. So fixed profit is fixed revenue, which is always 0. This is always 0. And minus fixed cost, which we calculated this way. This should be step 2, and that should be step 3, and that'll complete the second solution. Let's see, second solution is strategically a little bit better in a sense that you can find that x value directly. If the problem is asking you only this one, then second method, doing marginal profit, is superior. But if you have to find out marginal, not just marginal profit, but the profit, maximum profit anyway, then there's no way out of this integral computation and then initial condition business. Okay, we went through both solutions. Which one do you like better? I'll leave you there, and that completes this business application problem.